Good afternoon and welcome to our next edition of the OnPoint webinar series. Thank you very much for your time today. Before we get going, just a quick look at our agenda here. We're going to start with introductions, a quick look at the Optron Group. We're then going to look at the comparison structure of our scanning portfolio. And from there, we'll deep dive into each one of those scanners, from the Navos to the Trimble static scanning and then Excurrence handheld scanning. After that, we'll jump into a Q&A and we'll close up. The guys on this webinar today, it's Brent Godfrey. For those of you that don't know him, Brent's very much around from a technical sales and support point of view. Then myself, I'm Chris Keatley. And I'm the Field Technology Sales Manager. Just a quick look at the Optron Group itself. The Optron Group was established in 1986. We were the first Trimble dealer outside of the USA, which was established in 1987. And the Optron Group is structured with different subsidiaries and segmented and really focused by the different industries. We've got Optron Geospatial, and they're best known in the mining, land survey, and government sectors. We've got SciTech, which is, I guess, known in the horizontal construction industry, and they're best known for their machine control and those sorts of solutions. And then OnPoint SA, that's where we reside. And we really focus on the AEC industry. We've got Moyo, which I guess acts across all three of the different subsidiaries. And what Moyo would do is really look at integrating your workflows with our hardware and software solutions. At Building Point, we really focused on the AEC industry. And we're here to really transform the design, build, and operate phases of these building projects. And we do this by, the wide variety of our scanning hardware and software portfolio, and we integrate, our hardware and software and service solutions. We really look at the entire AEC industry as a whole, and we're really here to sort of streamline that communication, collaboration throughout the whole design, build, and operate life cycle. If we look at our different sectors within Building Point, in the architectural side of things, we represent SketchUp. Of course, that's where 3D laser scanning plays a role, and augmented mixed reality solutions. On the structural side of things, that's where our TechLab portfolio really comes in strong. Again, 3D laser scanning and augmented mixed reality. For general contractors, our layout tools are really prominent in that sort of sector. Again, 3D laser scanning and augmented mixed reality. I think you'll find what we've discussed here and what we're going to discuss here, 3D laser scanning and augmented mixed reality plays a role in pretty much the entire life cycle, and that's what we're going to discuss with you today. The whole idea behind this OnPoint webinar series is that we represent quite a wide variety of products. On the office side of things, we've got, as I've mentioned, we've got the TechLab, we've got the SketchUp, Trimble Field Link, Trimble Connect, and Trimble RealWorks. In the field, we've got both the layout tools from your sort of RI to your robotic total stations and your GNSS solutions. We've got 3D laser scanning, and there's quite a number of 3D laser scanners out there today, and of course, augmented mixed reality. The whole idea here is that we're really trying to look at integrating these hardware and software solutions and really optimize your current workflows. And at the end of the day, just improve overall collaboration. And that's really what we're hoping to try and achieve by these OnPoint webinar series. And I think, as we dive a little bit deeper into this, we'll get a better understanding for that. A quick look at our scanning portfolio. We've got, starting on the left-hand side, we've got sort of the iPad, and we build up, with a whole different sort of handheld scanning solutions to mobile scanning solutions and static scanning solutions, excuse me. And you'll see that as as we increase from left to right, we increase in both price and I guess output of these specific scanners as well. And what we're hoping to do today is just take a deeper dive into these particular scanners and see which scanner is best for which environment. I'm sure you guys would have noticed over time that there definitely has been a bit of a trend. We've got things started with sort of the total station side of things, and that's where you've got one setup is able to capture sort of several points, and then you've moved on to terrestrial laser scanning, where one setup collects millions of points, and we've then migrated into, I guess, an era where we've got mobile scanning or sort of handheld scanning, and this is really continuous mapping. You're just continuously collecting millions and millions of points. Don't get me wrong, I'm not saying that mobile mapping has replaced terrestrial laser scanning. I'm really saying that when it comes to scanning, it's really horses for courses. And what we're here to do today is to introduce you to these different forms of scanning and to try and give you an idea of what form of scanning is best for what environment. So yeah, on that note, I think what I'll do is hand over to Brent, and we'll get things going.
Okay, cool. Thanks, Chris. Thanks everybody for joining. So the aim of today's webinar is we're going to, as Chris has explained, we're going to try and show the topic of it is sort of the scan to BIM process. We're not going to you're not getting into the debate of what is BIM, and you may see products like a Revit or a SketchUp or whatever. It's about the tools and taking the tools from the different manufacturers and the different options and add-ons and look at what type of environment you're looking at, and maybe try and get an idea of where these can fit into what you currently do or what you're trying to do. I think it's not easy to decide. If we look here, this is just our Cape Town office. Chris has walked around with the different devices. We do loads of sort of testing and checking one device against the other to check performance. So we've got lots of examples of data comparison. And it's not easy to decide. I mean, if you look at these as an overview, in each one of them, every single one of them is producing a good quality data set. Nothing is that it is a difficult decision to make. And I think for today, I'm going to try and break it down into, what should we be looking for when trying to decide. It's a bit less about, a few years ago, we would have we would have been talking about specifications, and I can scan 2 million points per second, or I can do 1 million points per second. And a lot of it is now, it's about, there's so many different solutions that work in different ways in different environments. We need to understand what tool works in this environment you're looking at, and then also look at a lot of what the suppliers offer is the add-on. So it's the workflows of how you're going to get through that scan to BIM process with that technology that supplier provides. And it's not only about the hardware. I think a lot of it can also be about the collaboration. I think sharing data is as important as capturing the data. If you can't share your data with customers, or they're required to download specific software, and you're sending hundreds of gigs of files, you're not exposing yourself to what you're doing. You kind of, that collaboration component and sharing by the World Wide Web is a very important factor. Now when trying to decide what tool to look for. And I think I'm going to just start off with straight away, just diving into the thing that probably most people want to see. They want to see the head-to-head, what these tools look like. So yeah, it's just an example of each scanner, each sort of color-coded differently in that sort of walk around of our office. And just at this stage, the point of this comparison was just to see, it's just a global optimization comparison to check that if there's anything that stands out drastically between one technology and the next. You will notice that in some of these little bits that, like the smaller areas that define the detail may not be as defined with a certain product compared to the others. But that's not necessarily in this test, and we'll dive into it later. It's not a that can be improved, and it's all about understanding your product and understanding your environment and how they operate in that environment. But as a global test in a environment where it's quite common, where you know it's just an outdoor scene, quite a lot of features for things to lock onto. It's just an overall test. And there's no big difference between them. You do see it in these small things. You'll notice there that green line, that is our static scanner. I think you can't argue that. I think the static scanning is still, that's the benchmark. I think that's where everybody is trying, on the mobile side, is trying to achieve that sort of level of accuracy on the, so we kind of use that as our benchmark comparison, the sort of green scan in there as our, you know, as what we're wanting to achieve. But I think if we look at the noise of these data sets from all these devices, if you looked at SLAM a while ago, you would have seen a much different picture. It's come on such a long way. And if we just, what we're looking at there, and we're measuring that, we're talking, and this is around the entire building, we've got about, that's measured 14 millimeters. It's not easy to decide. There's not a lot in it. And just back on that point of sort of, you know, how we used to look at things and how we look at them now, I think a lot of people are more invested in the process of scan to BIM as opposed to just the point cloud and understanding, and now people understand more that process is more important than density, for example. So I'll just reiterate that. So like here, for example, is an example of a highly dense scan. So a scanner that scanned millions of points in a small area. And if we just look at a small example of that, a corner of that room, that's what it looks like, you know, extremely dense. And that's what it looks like when it's at a lower density. Now, if I'm the one doing any modeling and stuff like that, I know which one I'm going to choose to try and identify what it is that I'm modeling. So just, you know, touch on that point, density does not equal quality in my opinion. I'm going to start with, as I said, we've got the benchmark, the X9. That's our, we're going to look at the X9 scanner as our static scanner in this comparison. And if we look at that portfolio of scanners that sort of Chris showed earlier on, you'll see that this picture is dominated by 3 of what look like the same X9 scanners. And you'll be correct if you thought that they are the same, because inside they are. It's very cool. This X9 can be configured in 3 ways. We can have it as a 40 meter, an 80 meter, 150 meter, from 500,000 to 1 million points per second. And it's done to suit both your, you know, your project requirements, as well as, you know, the fact of the matter is the depth of your pocket at that time of needing to invest in a scanner, but without sacrificing quality across the range. This means that today, if I can afford an 80 meter scanner, but I'm concerned that in the future I might need something with a longer range, I don't need to worry that I have to invest in new hardware in the future. I can upgrade my existing hardware as my project needs dictate. And that's not the only configurable part of it. You know, when we talk about we can buy these things as a perpetual option. We can subscribe to them, a subscription to the scanner, which further assists in affordability and obviously being able to spread costs, lower insurance costs, be able to spread costs between CapEx and OpEx budgeting. So in a nutshell, it's a very configurable scanner, but doesn't compromise on quality, whichever sort of configuration you're looking at. Now, we have to look at the specifications a bit, but, you know, apart from the usual things that you'd expect from a high precision scanner, which is, you know, a range noise less than 2 millimeters, or full color and HDR color acquisition, sub-minute time setting for sort of indoor scenes. These are sort of common things across high-end static scanners. But what's I like about this one on the hardware side is also it's I mean, it's best in market leveling compensator. It's sitting at 3 seconds. So you're sitting in your total station territory. So there's no need to put it in survey control for precision analysis projects and things like that. The fact that it's self-calibrating, it's not only a cost saving and a reduced downtime, and obviously the confidence that you get that you're always walking away with correct data. I just find it very impressive at what the actual instrument is doing in the self-calibration process. I mean, it's doing a full calibration on its angular range systems, horizontal and vertical, and then it's correcting the collimation, vertical and horizontal axis for each scan for the error that it can find. It's even, I mean, it's got a built-in collimator, and it's calibrating the laser, and it's applying the correction to the distance measurements. Throughout the scanning, it's busy monitoring things like the outside temperature, the ambient light, vibration, the instrument temperature, and it actually adjusts the vertical speed of the scanner to make sure that it's actually capturing data at optimal performance at that point of time in your current environment. I mean, we talk, measuring all your environmental influences in each scan. And putting all those things together kind of makes it, and having this ability to have an immediate on-site sort of deliverable, being able to do registration of your data on site, so you can register and refine it. We've got that communication link where we're able to bring BIM models and 3D models onto our scanner, as opposed to having to take the scan data into the office and do comparisons over there. So we're able to do immediate deviation analysis and stuff on projects where they, right there in the field. Just adds more value, I think, to your investment in your scanner. It's a very efficient workflow. So if we look at sort of scanning environments, where I think, where you're going to opt for static, I think it's also important to note that everything you can, I don't know of an environment, everything you can do with a static scanner, everything a static scanner can do, you can't necessarily do with a mobile scanner. But the mobile scanner can't necessarily do everything that the static scanner can. It may take you a bit longer with a static scanner, but you can still achieve the final result with the static scanner. But sort of the best environments and things where it really shines is where that high precision is required. So we're talking that 2 to 6 millimeter range where mobile hasn't got to yet. It's trying to. They're pushing hard, but then it's not there yet. And that would be on projects that are cost sensitive. And when I say cost sensitive, I don't mean that because it's going to be cheap hardware to invest in, but rather where expensive decisions are going to be made on the data that you capture. Or more importantly, where expensive remedial action is going to be needed if your data is not 100% there. So, some of those examples would be things like floor flatness analysis, lift shaft verticalities, steel fabrication, steel structure, retrofit projects, things like modular installations and oil and gas things, where things are all prefabricated on land and then lifted into place, and all the bolt holes and pipes must line up with the existing plant. So I just want to, this is just a quick example of say, floor flatness inspection, but this is an example of why you need high precision data, and of how high precision points can be converted into real actionable data for decision making. So in this example here, for whatever reason, a floor during construction went wrong, levels are too low. And the first and most expensive solution was to add screed, because it's probably the easiest decision to make when the only data you're getting is from spot shots, example, from a dumpy level. But sometimes screed doesn't bond and you need to do a take two. And this is where you're looking for sort of more data to make a better decision. And because we scan all the data, we can look at lots of different things. So we can now calculate and reference against what is the cost to grind the floor versus what is the cost to put in a filling screed, and calculate that optimal balance between those two. And at the same time, also taking into consideration the impact that it's going to have on things like the door heights and the surrounding services and stuff like that. So it's more than just calculating an average level. That's only, it's about doing this analysis and and trying to find that sort of optimum cost balance between how to fix things. And that only comes because you've got access to high quality data that you can make trustworthy and informed decisions off of. And we see a lot of stuff on floors. This is just to show it doesn't always have to be a flat floor. You can do stuff where it's, this is a raking beam, it's a slope beam. It doesn't matter what the shape of your thing is. We can have precise measurable data that we can, that's contextual and that we can use to do these types of analyses on. So thank you, Lee and Ian, for these data sets, Lee Luttman and Cape Survey. One of the, and to do those type of things, those analysis, some of the workflow add-ons that Trimble has, specifically inside Trimble RealWorks, and in the latest version that was just released 2 weeks ago, there's a nice feature being able to actually do your point cloud to model registration, or model to point cloud registration. So doing that auto alignment of models to point clouds. And you don't always necessarily, you're not really interested in the deviation of the point cloud from the equator or your grid. Sometimes you're wanting to know object to point cloud deviation. And that's a really cool new feature inside there. The other thing that helps with the static data is, because of the structure of it, it's a structured scan data. There's lots of other information other than just a point and a color. Auto extraction on things like pipework and things is a lot more reliable and a lot easier and faster to do. So it's another thing that we sort of can do in RealWorks. Auto segmentation and doing sort of AR recognition of things. So we can, if you've got a busy plant environment and you want to do the steel structure, you can auto segment out all the steel beams, and it'll take out all the other plant and everything in there, and it'll just leave behind your steel beams. I can even model the, fit the steel beams to my point cloud from a catalog. The same as we can segment out the steel beams, we can also take out dynamic objects, moving objects. And also that, we can send that data to your modeling package, like sort of a Revit or a SketchUp, and it's not it'll send a native, like a Revit family object. So not just a geometry, it'll be a native Revit pipe, or if you like. So if you look at the collaboration side of what sort of the Trimble stuff offers, there's something we have called Trimble Connect Reality Capture Platform Service. It's part of Trimble Connect. And what Trimble Connect is, it's a common data environment. It's a place where you can quickly, securely communicate from the office to the field. You can access Trimble Connect from your mobile phone, from a tablet, from a computer, and you can load these 45 different file types that it can consume. And it's for project management, so you can add comments to files. You can issue tasks for people to do to-dos, or issue RFIs and NCRs via this application. Bring in 3D models, share version data for people to review and classify information. So it's a full project management common data environment. If we look at, this is just an example of a demo that we did in Cape Town. And So you can just see the point clouds loaded into the system. And the point clouds are structured in a way when, once they loaded into a format that is very fast for rendering and interrogation over the web. So this is viewing the point cloud in my web browser. And what's nice is obviously that's easy to share with everybody without them needing to install any point cloud specific software, having to manage large files, or have hardware that's capable of running these data sets. And Trimble Connect can handle massive data sets. So, I mean, you've seen city loads of entire street networks captured on mobile vehicles and mobile scanners. As you can see, you can load any of the data. So you can load both the point cloud as well as any other project data. So it's model data. So you can measure and interrogate the relationship between sort of any number of data sets and do run clash detection and all that type of stuff in this reality capture platform, in Trimble Connect. Going off a topic a little bit, I mean, you can view your 3D model from Trimble Connect on an iPad with Trimble Connect augmented reality. And these models are either located manually on site or via a QR code that's created inside Trimble Connect. And then if you see anything that's out of interest or out of place, you can use the LiDAR capability on the scanner on the iPad to do a quick scan of the point cloud and sync it up with Trimble Connect, and it'll appear into your project in its already georeferenced and geolocated position in the office. So, probably a topic for another webinar on its own, but I'm sure I can get peers on this call, but I'm pretty sure he'll be happy to come and share some of the amazing stuff he's doing with his X9 scanner and the AR and the MR stuff and this reality capture platform on projects that he's doing in South Africa and now actually internationally. So that's our 4 segments covered when it comes to the sort of the static scanning. I think now I want to move on to the new kids on the block. This is our XGrid's range of scanners. I'm very excited about these guys and what they bring to the industry, both their hardware and software performance, as well as their innovation that they're bringing on their performance. It's not just, they really are bringing new stuff and new tech, new applications to the industry. There's 2 different form factors of the scanner. There's the Lixil K1 and there's the Lixil L2, and both of them will bring a smile to your face, as this picture is factual proof thereof. And although there's 2 form factors, there's 4 options you can choose from. So the L2 Pro's got different configurations of the LiDAR, puck, a 16 or 32 layer, ranging from 120 to 300 meters. So within that XGrid range, that package, we can have anything from a 40-meter scanner up to a 300-meter scanner, from 200,000 points per second up to 640,000 points per second. And then the data accuracy with this, we're looking at around a centimeter on the point cloud accuracy. What's nice is what you saw earlier, it's not fuzzy data. The range noise is very low. And it's very versatile. So, this is another impressive thing about it. This thing it's drone mounted. It's got the capability of both RTK, PPK, and GCP processing. So, there's no radio module inside these scanners. So it needs to have a network-based correction service for the RTK, which is great that you can also have the PPK for, we don't always have reliable sort of TrigNet service 2 centimeter accuracy across the country. So PPK is really cool for bringing the GNSS capability inside the unit. And there's lots of other handy sort of mounting configurations and stuff that you can have with it. So I didn't want to leave this little bit outstanding. We saw this in that introductory video. So I just wanted to sort of in that where we looked at the global comparison between the different data sets. So I just want to sort of show you what can be achieved, and it's about sort of understanding your equipment. It's about understanding the both the capabilities and the limitations of your device. So here we can see a data set. This is one from X-Grids themselves on using their K1, which is the entry-level scanner. It's in an outdoor environment. But here, obviously, the purpose they want is to show the detail and the final performance that you can get out of the SLAM unit. They've obviously applied a sort of a more focused and slower approach to the data capturing. But you can see we can also, looking at the same sort of window inlays as before, we can by knowing the limitations and the capabilities of your product, you can get really good performance out of these units. I mean, this is. I was pretty impressed by that scan quality from sort of the entry level SLAM device.
I think it's just important to note the colorization there too. I mean, you're getting really good, clear and crisp colorization out of that entry level device as well.
Yeah, absolutely. Yeah, I mean, it's also to note that on the cameras and things it's using, I don't think I've mentioned that it's not just a SLAM device, it's using the cameras as well. You're doing sort of the visual odometry as well. So it's got cameras dedicated for color capture and other cameras dedicated for tracking, as well as using the LiDAR for tracking. What I like, so I just want to share this is just an example, and I just want to, I think just because I was surprised by the results of this, I think if anybody had looked at SLAM in early days and we looked at some of the technology just a couple of years ago, in this type of environment, I wouldn't have expected a closure. You see, there's no feature. So there was no GNSS applied with this. It was purely, there was no, it was just the L2 on its own. But that cleanliness of a SLAM data set was very impressive. I think if you had looked at SLAM a few years ago, and, these are the kind of, I always zoom in here on the curves because, I mean, I think those are things that you would beforehand, if you had used this, they're quite hard to define, those break lines, those top and bottom break lines and things like that. But now, very achievable. Other applications, I think, these devices are good at, just a sectional title surveys, applications for open, and it also, the software that comes with the X-Grids also does enclosed volumes as well. So so for tunnels and underground applications. And you'll notice also the data sets are quite clean. It does auto, taking out the removal of dynamic objects and things like that is all handled within the processing of the data. And sticking on the underground topic, they've got specific profiles for narrow scene profile processing, fusion processing, where you can take multiple data sets, process them together, and the global optimization will be applied to multiple data sets within that single process. So if you just to eliminate drift and non-overlap of different data sets, they don't have to be captured in the same environment. They can be, as long as common points are measured, and they don't have to be georeferenced common points. But back to the topic, we were saying we were going to look at sort of the scan to BIM side of things, and X-Grids brings another element to it where they bring the 3D Gaussian splatting into the mix. There's kind of two parts to X-Grids on their software side of it. There's the traditional point cloud processing where we saw sort of the volume calculations, dynamic object removal that happens inside Lixil Studio. And then there's the 3D Gaussian splat side of things, which is processed in a different package called Lixil Cybercolor. Yeah, so the simplest explanation of a Gaussian splatting that I've sort of managed to come up with and found, and is that, what it's doing is it's the conversion of multiple images, and in the case of X-grids aided by the LiDAR in this case, to create a representation of 3D space, and then use this representation to create images as seen from any new angle. So the result being to see a scene from any angle, even though you never occupied that space while capturing the initial data set. You can Google what Gaussian splat is, but be prepared for some heavy formulas and big words. I like to accept maybe it's just a little bit of magic. It's just easier to get my head around. So here you can see just some of that little bit of magic, where you can see sort of the 3D Gaussian splat alongside the point cloud, where where we apply this magic formula of PC plus 3DGS equals V1M. But you can clearly see the sort of the benefit of having that clarity of scene when doing the modeling. Take it one step further, and you apply that X-grids. There's also direct integrations and plugins with Lixil Cybercolor with Revit, for example. So here you're seeing sort of the scene, obviously Revit on the left-hand side and Lixil Cybercolor on the right. And as I navigate, and I can be navigating either in Lixil Cybercolor or in Revit, and sort of the two and the views are synced with each other. And it's really cool for, point clouds are great, but sometimes to identify the smaller objects, trying to identify what basin should I use, like in there, what tap configuration is there, to try to look at those smaller details. It's just so much easier having just on that screen alongside you, having a view of what the real world looks like with such clarity. Comparing it to trying to pull out small objects from the point cloud. And these are measurable as well. So I can, while I'm inside here, I can take measurements of my Gaussian splat as well. But just fast forward a bit there. So it's not just viewing, it's great for having that for your QA, QC process. But I mean, I can also turn on my models. I can have my model inside my inside LCC as well. So that's your direct comparison to see if where things where there are deviations or changes during that modeling process. But there's also extraction tools as well. So if there are, for example, I can create walls by just selecting objects inside my LCC scene, and it'll generate them inside Revit. And that also applies. I can choose the type of wall that I've got loaded inside my project. The same applies to doors and windows and that type of thing. So that workflow of going from is really, they've thought about it, and they know where some of the pain points and stuff are. And these little add-on tools, they really help in that process. Here, get to the final bit on the X-grids, on sort of on the collaboration side of it, and I wanted to stick a bit more on the Lixil Cybercolor and the Gaussian splat side of things. This is that Cape Town office scene. This is showing. I want to show this in real time. So I have now selected and my project and said I'm going to post it online. If you look at the size of the file that's busy being uploaded here, the point cloud dataset was 15 gigabytes of that office scene. And as this, you can see as it's loading up here that the LCC, the splat it's about 30 megabytes. So that's it already done. So I've posted it. It's now hosted online. I can then very easily just take get a link from my Elixir Cybercam, and I can share that link with anybody. Anybody can then open up inside their web browser, paste that link, and it'll take them to LCC online. And then they can have access to your data set in this type of format, so they can navigate around your entire project. And as I mentioned, it's measurable data as well. So inside it's not just the pretty picture. It's got scale to it, so I can take measurements and get information out of it. You can also tag things inside before you publish it. So if I wanted to add information about certain objects, I can add a PDF, or I can add a link to another website, and you'll have all these notes and things posted around your scene. So for a facilities management application, for example, I can add information about plant or objects or things like that that are inside my scene. And then if you want as well, you have a bit of fun with it, see a challenge in life, go for it, take it on. I think the point of showing this is just to see, this is showing that it is that whole data set, that's 30 megabytes, and just how easily it renders, how quick and fast the stuff renders in real time on your web browser. So as far as a collaboration and sharing platform or way of sharing your data, I wanted to receive data on a project and I was offered a point cloud or a link that runs like this with this clarity, I know which one I'm going to choose. I think if we look at now Naviz, so now there's two form factors of the Naviz. We have an MLX and we have a VLX. I think there's two versions. There's VLX2, a VLX3, different ranges on their scanning capabilities, different densities. You're looking at around 5 to 6 millimeters is what you're getting on the accuracy of these from a VLX. Also full 360 panoramic views or bubble views, if you like, hour and a half hot swappable battery life. So it's a high performing unit. I think if I don't know if I get into trouble, but it's I'd say this is the Rolls Royce. This is probably, when it comes to accuracy and clarity of data inside for a SLAM unit, you're looking at the Rolls Royce. So the usual things, you can compatible with ground control points, so you can eliminate sort of drift and things like that. And this is a data set done by Cape Survey. I really like it just because it's a basement, it's a car park, and if anybody's ever had to sort of to do any scan to BIM on environments where there are lots of services, lots of pipes, and one needing to differentiate between the different pipes, capturing that data with a static scanner is going to be extremely time consuming. To be able to capture something with this amount of, and it's about the coverage. There's no shadows, there's no blind spots. The entire data set it's complete. And when we've got pipes inside there that are sort of 30 millimeters in diameter, it's very easy to identify the clarity of all the small items, and also the color component of it. It's easy on the eyes, but it makes it easy to work with as well. But it doesn't always need to be, and again, thank you, Cape Survey. It doesn't always need to be a complex big oil and gas project or something like that you're wanting to that you need to invest in something like this on. It can be used for scanning for traditional architectural projects, and residential housing, for other commercial units. I think the point is if when you've got a device that captures this high quality data, it's quite easy to produce high quality models from it. Your likelihood of making mistakes because of missing things is greatly reduced. There are no shadows or blind spots where you may miss things. And it doesn't even have to be necessarily a 3D project that you're after. Even a deliverable for 2D could warrant investing in a 3D in the NAVIS scan, just because of that process. Getting from scan to BIM with good quality data is it's just a lot easier with that good quality data. Look at the MLX, the handheld, the smaller version, say the baby brother of the VLX. Definitely not baby in its performance, small in its ergonomics, but not small in the quality of what it produces. Same as the VLX, georeferencing on control points, process is the same in iFilm, which we look at just now. And it's a more compact and mobile version. So, if I look and try and say where I would best want to deploy something like this, an application, it would be in a smaller, maybe 1,000 square meter sort of environment where it's complex and it's dense, but you still want to have that speed of acquisition. Not having to, in this small little plant room, to be able to get this coverage from a static scanner, I don't know how many setups, probably guessing 20 to 30, and it's very small, and it's a very small area, as opposed to a couple of minutes, and yet you're still getting that sort of really high quality data set. And a lot of applications at 5 millimeters, that's that's sufficient. If we look at the Avion sites, and the Avion, this is the shareability, or the collaboration, I'd say, side. It's also the processing side of NAVIS. This is what it would look like, how you would share your data with clients. You go into like a Google Earth, Google Street View environment. You can see all your projects. Choose your project either from the drop-down list or from the map, and then you dive into your starting scene. And each one of those spots are a location where 360 panel has been taken. So I can jump into and navigate my environment either through clicking on a spot from my 3D view on my 2D plan, and it's easy to just toggle between the two. You'll notice that everything is also nicely laid out and split up onto the level. So I can go going from ground floor to second floor to first floor. And sometimes in that scan to BIM process, and when modeling, it's quite difficult when you've got a data set and you very often need that visual aspect of it. You need that 360 panel, you need that photographic context. And to find that single, especially when you've got multiple floors stacked, unless you go through the process of splitting up your data and having different data sets for different floors, to try and find that individual spot where I'm wanting to see things from, can be quite tricky. You'll notice inside here as well that there's all these tags, these little points inside my data set, and those are what we call points of interest. And these are, you can add. In that last example, that was those were sensors based on that live sensors from that piece of equipment. So anything that's got access to an internet and sending data out, you can pull in and feed it through this through this platform. We can have this like work order management systems. There's a maintenance schedule, so guys can go in and do their maintenance on products, on tools or pieces of plant, for example. They can use this user interface to get access to not only to see where it is, but also have all the manuals and service history and what needs to be done, all linked inside Avion. So this kind of deliverable is, I suppose, is as close to what I would consider an out-the-box digital twin that you can get. I mean, you can even do navigation, so you can navigate from point A to B. So there's some pretty impressive integrations people have done with like SAP systems, with work order management systems, where you can send people jobs. It even takes them, navigate them to the location. And there's a version of where you can actually use it's called Avion Go, and you can wave your phone around, and your phone will recognize the scene, the imagery of your phone will position you inside your environment based on the video feed it can see, and you'll see yourself on Avion, and you can then select points and navigate to, and you can track your movement through by using your mobile phone. So very cool application. Also, I mean, it's not just the imagery. As you can see here, this is the point cloud as well. So it's also got all the point cloud capability and online. So again, no need to share big data sets with clients. You can just share links to them, and you can decide whether they can have access to download the data or not. Perhaps you do want them to have it, perhaps not. You decide what rights you give to what people to access your projects, whether they can add points of interest, whether they can see those types of points of interest. So there's lots of collaboration that can happen through Avion. So it's beyond just the capturing a point cloud. There's a lot of delivery benefits to Avion, and to the Navis system, to the whole Navis system. I think just want to show the last thing also, similar to how XGrids also has a integration into things like Revit, so does Navis. As you navigate around through your Revit environment, you can click anywhere in your model and you just say locate. Click on that scene and say locate, and it'll locate you to the closest 3D bubble view within your Avion project. So again, it's that time spent trying to get to the information that you need by having these two systems talking to each other. And also, while you're busy working inside here, you've got the access to the measurements, taking the measurements inside Avion and using them inside Revit, and doing, if there's an area that I'm wanting, you don't have to share the whole point cloud with people, so you can do like a little crop and a download and say, okay, well, just want to crop the small area of point cloud, and whether if I'm working in ArchiCAD, I can download that little segment of point cloud as an E57. If I'm in Bentley, I can download it as a pod file. If I'm in Autodesk, it'll be an RCP files, and I've got all that sort of access that we're giving to the client to choose whatever they're working in. They can access the information how much they want in whatever format they want. So I suppose brings us back to that question. We try to look at those sort of four areas to sort of compare the products to each other and say, how are we going to decide, which product is best for your project. Sorry, I don't have the answer yet. I think the answer is going to be, if you've got a project, and if you're considering getting into scanning and you're wanting to know, you've got an idea of where you think you want to make your money, who your existing clients are, what type of work you're wanting to get into, then give us a call. And we've got all these, we've got demo equipment of all these products. So Chris will come out and we can do demonstrations, and we can see what you're trying to achieve, and we can help you with that. Not just which button to press to start the device, but how to, let's see how we can help sort of deliver something. And just on a point, we've got all these different products, XGrids, Navis, Trimble, and stuff, and we don't have them because we were able to get hold of them. We have them because they are the best. We didn't just go out and get anything. We know when we saw we can see what the need is. We're talking to people all the time. We can see what guys are asking for in the industry. We see what the need is, and we've bought on X-Grids and we've bought on Navas, and it's because they're the, you know, they are the top of the pile. So yeah, we'd be happy, really, you know, I'm sure Chris would be more than happy to actually show you, get out and show you guys this information on your projects, and maybe answer some of the questions that you have in trying to decide, make this decision of what device to use, because it isn't an easy one. It's not getting easier. As the tech gets better, actually, yeah, that decision is getting harder. But you know, hopefully we can help you in that decision-making process. And yeah, so I think maybe if we do have any questions, we can. I'm just going to see if I can. Maybe we can put them in the chat. If you guys do have any questions, let's see. Oh, there's loads.
Hi, Brent. You do have a raised hand.
Okay.
Mandisa is asking a question.
Yeah, I'm going back now if you respond, Roy.
Hello everyone.
I'm Mandisa.
Hi, I have a question. I have two questions. They're not really like related in selecting the suitable scanner, but first one is, how do you, like, I understand that when you're scanning with the X-Grid scanner, it takes like 360 panoramic images. So is there like a technology that's like automates, or you have to like post-process the point cloud, also the images where you have to remove like the image of the person taking the scanner? That's one. If like, is it like it's automated? And two, if like you have showed us that you are able to walk through like the building as you have showed us, if you are able to also open that kind of effect in like other environments, like in a GIS, or are you only able to walk through using the software that you use? I think it was Lexel Studio, if I'm not mistaken.
So on both those questions, yes. So during the post-processing software, it takes out dynamic objects, removing objects. That's it. So yourself is removed from the scene, so you're only left with the point cloud. So you're not in any of the imagery. The point cloud is cleared. Also, so it's not only yourself, it's anything else that's moving in the scene. It's moving vehicles, other moving people. All those dynamic objects are recognized and automatically removed. As far as the viewing it in other software, absolutely. So the Lexel Studio, you can output, so the Gaussian splat will export a PLY format, which you can bring into other applications. There's lots of integrations with Unity and other software packages. And I think about a week ago, even Esri announced that they're going to be integrating 3D Gaussian splats into their GIS environment, and I think it's going to come in November. So there are lots of different, you know, the format is not closed. They offer it. Lexel Studio is offered, and then it's not a closed thing. You can export into a common format, which is a PLY format. Most applications can consume that, and more applications are consuming Gaussian splats. SketchUp's release is probably coming soon. There's a lot, yeah. It's so yes, and so the GIS coming soon as well with Esri.
Thank you.
That.
Brent, I see that there's 1 minute to go, but would you like to go through the go through the questions in the chat?
Yeah, so let me just go through some of the questions. Well, there's only a couple of questions here, actually. What's the minimum entry SLAM scanner? I'm assuming meaning entry level on cost. I think if we looked at that sort of scale from left to right, That's kind of where they sit. So it's our K1 is our entry level scanner. I mean, all these things they range from around the under 200, between 150 and 200,000 rand, up to just over $1 million on the upper end of the scale. But that's what that's sort of their pricing. So pricing on these units just in the last couple of years, it's a dramatic. It's a big change. They're becoming more sort of consumer tools. So access to them is a lot easier than what they used to be.
I also think in order to give a sort of more accurate price today, Fred, we'd have to, if you don't mind, maybe reach out and maybe discuss exactly what you're trying to do, your current workflows, and then we go from there.
Different add-ons and plugins that you require. So Brian's got his hand up. You want to go ahead, Brian?
Hybrid. Yeah, thank you very much. I just wanted to ask a question on the K1. You have got a sample set that I'm looking at. The K1, considering that the LiDAR sensors on the top, how is it capturing ground data in front of you? Because as soon as you tilt it too much, it stops scanning. So like working indoors is phenomenal. The results I've had from it are really, really good. It's just I'm waiting to see something on the ground, and I'm interested to know how that's going to work for outdoor scans.
So I mean, if you looked at those scanners that are the videos, the fly-throughs they would do, one of them was the K1, and there was no real sort of reduction in the sort of, there was still dense data on the floor. And you're right, it's just the configuration of the scanning head of that unit. So when you walk, it's sort of configured. So you walk with it sort of, you're probably capturing data maybe 3 meters in front of you. So if you are going into a very confined space, as I say, it's about understanding the limitations and it's not the limitation, but it's the how to operate the scanner. So if you're going into a small space, you would need to hold it closer to the floor to capture the ground data. In an outdoor environment, when you scan range is sort of 40 meters, but you're picking up the floor because of the way you're holding it, probably 3 meters in front of you. So
yeah, so on those data sets.
So what I'm saying is, like, if I want to survey a manhole, yes, you're going to be getting curbs and street data normally holding it, but a manhole, so you normally want to be like looking down on it. If I'm explaining that well.
Yeah, 100%. So this is why we say it's for the different applications, they've all got their strengths. That's one of the the strength of having a rotating head SLAM device is because especially if you're crawling around spaces and you're wanting to get inside roof spaces and things like that, it's probably best to have a rotating head, a rotating scanner. You can turn so the device doesn't stop scanning when you turn it upside down. It's not advisable to walk with it upside down because it's it'll give you an error, and it'll say, because you can also capture control points with it on the floor, on the wall, that type of thing. So it's not it wants to be kept in a certain orientation, but it'll give you a warning because it's outside of what if you continue to do that, it may not process properly. So yeah.
Okay, I see, because that's what we had when we tipped it like forwards, testing that, it came up with the error saying please level, and just from what it looked like, it wasn't getting any data. I was just like, oh, okay, so that's obviously, look, horses for courses, like it's indoor is amazing. That's just something one would need to bear in mind when doing that sort of stuff.
Yeah, and still, like, if you tip it upside down, it's not going to stop collecting data. It's still very much collecting data.
Okay.
It's just more of a warning. But what I can also tell you, like, so I physically did all the data captures of those different sort of walkthroughs that we were showing a few slides before. And the one with the K1, if I'm very honest, I didn't actually take notice. Yeah, so on this slide here, this one of the K1 on the top left, I didn't really take notice that I was holding the scanner correctly. I just sort of grabbed the scanner and just started walking. I mean, I think subconsciously I must have taken notice, but yeah, and you can clearly see that you did get, or we did capture more than enough data on ground levels there. So I think you'll be surprised by
For me, it's not the ground data is pretty decent, like what you think, but it's when you're looking for finer details in terms of like manholes and stuff, and you're wanting to capture certain corners, then I don't know about it. But indoors is really, I'm just talking about the K1. That's all I've really played with. Indoors is really good. It's probably the best one I've had indoors for my 10 cents.
Upsell opportunity for you, Chris. There goes. You just lost your K1. You're getting an L2, Brian.
No. Look at the price level. The K1 is by far the best. It's there's nothing that touches it in that sense. And we've gone through a lot of scanners. We've tried a lot. That would be my only like thing with the looking down. But I haven't tried the tilting it. So Chris, maybe I can try that with you, tilting it. And other than that, yeah. Sorry, that was my only question.
All right. I don't know if I don't see any other questions or hands up. The webinar will be on our posted on our website. I believe a link will be sent out to everybody that has registered. And yeah, if you do have any questions, please follow us on our social media platforms and get in touch with Chris. He's your local man on the ground, and yeah, hopefully we can help you out. So thanks very much, guys.
Thanks, guys. Thanks for your time.